Okay, in this video, we're going to introduce the time value of money. This is going to be a super important topic. I think the best way to introduce time value of money is to just start with a problem. Okay. I think when we start with a problem, you can kind of get at least some application of why time value of money is going to be important. The problem reads: suppose your parents loved you and they contributed $5,000 to your retirement account on the day you were born. They invested this one-time amount into an index fund that tracked the S&P 500, which has paid about 12.5% per year on average over the last 100 years. If you are able to return 12.5% each year, how much will your account be worth when you retire at the age of 65? So this is a pretty straightforward question. Your parents, I'm sorry, I'm being a little facetious. You're going to find out that your parents may love you a little bit more had they done this. If they were to contribute $5,000 into a retirement account on the day you were born and got 12.5%, what would that account be worth when you retire in 65 years? Okay. So what we're going to do here is I'm going to go into Excel and we're gonna do this here. So we have a balance. So year zero is the day you were born. Year one is 1 year. You're 1 year old on that day, your birthday. 2 years old on that day, and so on. This is the balance on the day you were born. They put the $5,000 into the retirement account, and you have 12.5% per year. I'm going to drag the 12.5% down all the way to year 65. Okay. And then what we're going to do is we're going to figure out what the balance is going to be in each year. Okay. So the way that I'm going to do that and follow this formula here, I'm going to take the balance from the previous year and I'm going to multiply it by 12.5%. Okay. So this is going to tell me the interest that I'm going to get from the $5,000. But notice that I have to add back in the initial $5,000. Okay. So in parentheses here, this is the interest that I'm going to get, and I'm adding back in the initial $5,000. When I hit enter, I'm going to have something more than $5,000. This is going to be $5,625. Okay. So in other words, I got $625 of interest. I'm going to do the same thing in year two. I'm going to say this equals the previous year's balance multiplied by my rate of return. This is going to give me the interest that I've earned from years 1 to 2. I'm going to add back in the previous year's balance. And when I do that, I'm going to get 6,328. Okay. So now what I'm going to do is I'm going to copy this down, and this is going to populate the balance in each year from years 1 to 65. And when I do that, you're going to see that your parents could have loved you a little bit more. Look at that number in year 65. That one $5,000 lump sum payment has become $10,565,352. Okay. So this speaks to the power of time value of money. And I think starting in Excel and seeing how interest compounds upon the previous year's balance is important. When you're 3 years old, that $5,000 had become worth $7,119. When you're 18 and graduate high school, that $5,000 has become $41,659. When you graduate college, something like $75,000 or $67,000, and so on. And through time, the interest is compounding on each other on the previous balance until eventually at age 65, that account is going to be worth $10,565,000. Okay. So this speaks volumes about the power of time value of money. Let's talk more in depth about maybe some terminology that we're going to use, and then we're going to talk some more about maybe the formulas that we're going to use. Before we get into that, let me just explain a couple of things. Okay, if this here is a timeline, this is important terminology that I'll use maybe throughout the rest of the videos here. If this is a timeline, so time is you're young here, you're zero here, and you're going to age 65 here. So this is the present and this is the future. Whenever I take a present value amount, say the $5,000 on the day you were born, and I want to evaluate what that present value is going to be worth in the future, I use the term compounding. Okay, I'm compounding interest on that present value to determine what the value of that account is in the future. Now, there are going to be problems where I'm looking at some future value. Like think of a company that is going to obtain some amount of money at some point in the future due to some productive activity. And what I might want to do is I might want to look at that future value, and I might want to bring that future value back to the present to see how much that future value is worth in today's dollars. In which case, I'm going to use the term discounting. Okay, I'm discounting that future value back. All right. So understand the difference. I'm going to use the terminology compounding when I take values out into the future, and I'm going to use the term discounting when I take future values back to the present. Okay. So let's talk about some of the formulas that are going to be important here. All right. If you notice what we did in Excel there, we took the previous year's balance and we multiplied it by the interest rate, and then we added back in the previous year's balance. So the future value of that previous year's balance, I'll call that the present value. Notice that I multiplied that by the interest rate, and then I added back in the previous year's balance. I can rewrite that equation as the future value is equal to the present value times 1 plus r, okay? And that gave me the future value the following year. Does that make sense? If according to our problem there, I took the $5,000 and I multiplied that $5,000 by 1 plus the rate of return in decimals is 0.125. Okay. And if I do that, then I get the $5,625 that we had in year one. So this is the future value of year one is going to be equal to the present value times 1 plus r. That allows me to take the present value and multiply it by the rate of return, and then add back in the present value from the previous year. Does that make sense, how that formula works? Okay. If I want to find out the future value in year two, I'm going to take the present value times 1 plus r, okay? And that gives me the future value in year one, and then I'm going to multiply that again. So let me put this in brackets here just so you understand. So this number here in brackets is going to be 5,625. This is going to be the future value in year one. I'm then going to multiply that again by 1 plus r. Right? Does that make sense? Or what I can say is this is the present value times 1 plus r raised to the power of 2. Okay. Let me superscript this to give you the proper notation there. So the future value in year two is going to be the present value times 1 plus r, which is going to be the future value in year one. And then I'm going to multiply that again by 1 plus r, or I can rewrite that number as the present value times 1 plus r raised to the power of 2. Okay, and of course, we know what that is from the spreadsheet. That's going to be 6,000, I think it was 6,100 or something, $6,328. Okay, so the future value in year three is going to be equal to the present value times 1 plus r raised to the power of 2. Give me a second here to superscript that. Okay, so the present value times 1 plus r raised to the power of 2 is actually the future value in year 2. And I'm going to multiply that again by 1 plus r. Or this becomes the present value of 1 plus r raised to the power of 3. Okay, and so and so on, right? We can do this again. Right, we can do this for year 4, 5, 6, all the way down until we do this for year 65. The future value in year 65 is going to be equal to the present value times 1 plus r raised to the power of 65. Okay. In general notation, all right, in general notation, the formula for future value is simple. the formula for future value in general notation is 1 plus r, the rate of return, raised to the power of t, where t represents time, or the number of years, or the number of compounding periods. Okay, so this here is going to be the formula for future value that we use. All right. When we come back in my next video, what I'm going to do is I'm going to rearrange this formula in order to solve for different parts of this. So in other words, if I wanted to discount a future value back by present value, I'm just going to use some algebra to transform this equation to solve for present value. I might want to solve for the rate of return. I'm going to do some of that as well. So I'm going to rearrange this formula here in the next video, and we'll pick up there, and then we'll start to work some problems.